Hey, welcome back, AP Calculus. We're looking at for 3 derivatives of inverse trig functions. Now, I wrote them over here. They're also in on your cheat sheet, so you don't have to rewrite these if you're taking notes, but just wrote them in this fashion so that we can kind of see how they're related. So we don't have to memorize all 6 of them. We can remember 3 of them, and then the 3 of them are the negative versions of them. So notice that sine inverse and cosine inverse, the cosine is just the negative of the sine. Same with tangent and cotangent, and same with secant and cosecant. So if you can remember one, then you just remember that its counterpart is the negative. Okay, so let's look at the first example. It's saying to find the derivative with respect to x of sine inverse x squared. Now, remember that anytime we have an inside function, and it's not just an x, right, that we need to chain rule. So notice this would be our inside, right? So inside, or our u, right? Our u is the placeholder for any function that could be plugged in there. So when we do this, we're going to do the sine inverse 1 over square root 1 minus x squared. But we also have to remember that because we have this x squared inside, minus x squared. Okay, so time out. And that's an easy one to forget too. So actually our inside is x squared, so it's that thing squared. So it's going to be x squared squared. And then we also have to remember the chain part. So the inside, the derivative of x squared is 2x. So the simplified version of this is going to be, well, 2x can go in the numerator, right? 2x times 1 is 2x. And in the denominator, we can simplify it because x squared squared is x to the 4th. Okay, so be very careful and remember that the x squared stays the same, but this also has a square, so that's why we get the x squared squared here. Okay, so the next one is some application, another problem involving particle motion. So on the x-axis, this particle is moving left and right, or right and left. So the position is modeled as x of t equals tangent inverse of t. What is this? Velocity at t equals 16. Right, so remember velocity is the derivative of position, right? So position, then we take the derivative to find the velocity, and we take the derivative to find the acceleration. Right, so because we're going position to velocity, we have to take the first derivative of this. So let's go ahead and do that. So the derivative with respect to, well, I guess we should say t because our variable is t, of tangent inverse of square root t is going to be equal to, let's go back here just to make sure, I think it's 1 plus x squared, if I remember correctly, or x squared plus 1, yeah. So 1 over 1 plus, or x squared plus 1, either way. Let's go back. So we have this as our inside function again, right? So we have square root t squared plus 1. And then we have to make sure we do the derivative. Now, the derivative of that, again, like we ended off with last time, that's the same thing as t to the 1/2 power. So the derivative with respect to t would be 1 over 2 square root t. Okay, so the nice thing here is that the square and the square root cancel. So we have t plus 1, and then we have times 1 over 2 times square root t. I'm going to say that you could probably leave it at this because we're just going to plug in from now. So there's no use in overcomplicating it. So at this point, because we found our derivative, we can plug in our t. So we're going to have 1 over 16 plus 1 times 1 over 2 times radical 16. So this is going to be 1 over 17 times square root of 16 is 4 times 2 is 8. And then when we multiply 17 by 8, where's my calculator? Seventeen times 8 is 136. Okay, so its velocity is 136, which is super tiny. Let's just make sure that I did it correctly. I'm pretty sure I did, but doesn't hurt to check. Yep. Okay, perfect. All right, last one. We're just doing this, just keeping in mind more practice, and we need to be good with our chain rule on this one. So the secant inverse, let's go back here, is 1 over absolute value of x square root of 1 minus x, or square root of x squared minus 1 positive. Okay, so let's go back here. Whoops. So this is going to be 1 over absolute value of x square root of 5x to the 4th squared minus 1? Minus 1. Minus 1, yeah. Okay, and we also have to make sure that we chain it. So the derivative of our inside, 5x to the 4th, is going to be 20x cubed. Oh, sorry, and then this x here. This should be 5x to the 4th. Right, because that's our inside. This is where our u actually, right? So then our u goes in here, our u goes in here, the insides go in there, and then the du goes here. Sorry for the confusion. Okay, so this thing is fine. There's no number we can put in for x to the 4th that's going to make it negative, so that stays. The absolute value is itself. On the inside, we have to square the 5x to the 4th, so that's going to be 25 x to the 8th minus 1. And then on top, we have 20x cubed. So we can simplify this a little bit, right? So 20 and 5 are divisible by 5. And then we can take all the x cubes from the top and cancel with 3 of them on the bottom. So in the end, we have 4 over, we just have that x left. And then inside our square root, we have 25x to the 8th minus 1. Okay, so just some more practice. Working with the inverse trig formulas. Keep in mind that you might see them, you probably will see them a little bit here and there on your calculus test, but then there are some of the lesser used derivative stuff that we're going to come across. So be good at them, practice them, memorize them, but we're probably not going to see as many of these as we see of the other ones. Okay, good job today.